we know that every human needs energy to support their life activities. And I have data from the BPPT in 2018. We can see that is every year BPPT predict the energy consumption in Indonesia will be growth significantly, and the highest energy that is used in Indonesia is oil fuel. It's around 30 until 40%. And this is also from BPPT. This is the energy balance of crude oil in Indonesia. As we know, the oil fuel is the non-renewable energy resources. That's why the production will be decreased by years. In 2016, we still have crude export, but BPPT predict in 2036, there's no more crude export from Indonesia. And BPPT also give us the graph that we can see the crude oil consumption will be not decrease it. They will always increase every year. So that's why we need to find a new energy resources that is renewable and environmental friendly. And the oil fuel in Indonesia, there's some type, and the highest is the gasoline. It's around 40%, and the second one is kerosene. Kerosene is 37%. That's why in this research, I focus on the try to produce the biodiesel and learn about the kinetic study. Biodiesel has some advantages, such as biodiesel is renewable energy resource, of course, has high efficiency combustion, high certain number, and also high flash point. So biodiesel is better than diesel fuel or kerosene. So what is biodiesel? Biodiesel is a monoalkyl ester produced from triglyceride transesterification or free fatty acid esterification. In this research, focus on esterification. Why? Because this research is advanced experiment from the Maria's experiment. Esterification is a reaction process of free fatty acid or FFA with the short chain alcohol like methanol or ethanol to produce fatty acid metal ester or FAM and waters as byproduct. Esterification usually use acid catalyst like chloric acid, sulfuric acid, or phosphoric acid. Simple mechanism reaction, we can see the fatty acid added by some alcohol and can produce the ester and waters. Acid catalyst has some disadvantages. That's why Maria's experiment used ionic liquid catalyst to produce biodiesel. Ionic liquid catalyst can be defined as a liquid that consists of cation and anion, organic salt in liquid phase at under 100 degrees Celsius. Ionic liquid has some advantages, such as experimental friendly, good thermal stability, high solubility, low vapor pressure, easily separated, and can be recycled. The previous research that I used to be a reference is Mas Aulia in 2012. His thesis title is Simulasi Kinetic Reaksi Transesterifikasi Minyak Goreng, or in English is Simulation of Kinetic Transesterification Reaction of Cooking Oil. And Fernanda in 2019, the title is Optimization and Kinetic Study of Biodiesel Production through Esterification of Oleic Acid Applying Ionic Liquids as Catalyst. My experimental target is first determine the kinetic model of esterification. Second, validate the simulation and experimental of kinetic model. Validate the reaction order from the experimental and simulation. And last is determine the parameters of kinetic model. This is then my experimental flowchart. First, of course, literature study, choosing the right reaction equation. And after we choose the reaction, we must linearization of the equation. And then we have final kinetic equation, the xa per dt. And then we guess the k value. After we have a k value, we can do the MATLAB simulation. And then we have the result validation. And then after that, we determine the reaction order. And last, we have the final kinetic model. This is the simple reaction equation. A plus B become C plus D. A is FFA, B methanol, C fame, D waters. Or the reaction rate equation, the overall reaction rate equation is mean RA equal to mean dCA per dt equal to K concentration A, concentration B minus K2, concentration C, concentration D. I assume there's no reverse reaction because this is the pseudo-homogeneous reaction with the excess one of the reactant, that is methanol. And the reaction equation become to mean RA equal to mean dCA per dt equal to K1 concentration A, concentration B. And then for the first order reaction equation, of course, we only see the only one of the reactant, and I choose to concentrate on the FFA concentration. And the final equation is ln Ca per Ca0 equal to K multiplied by T. T in this is time. And the second order reaction rate, the final is ln Ca per Ca0 square equal to Kt. Okay, this is the graph. The spot, the dot is the experimental data, and the linear line is a simulation. This is simulation use K value from the Maria experiment. And then this one is the sulfuric acid. Also use the K value from the Maria experiment. And we can compare both of the graph. We can see that is there is a difference between ionic liquid and sulfuric acid. The ionic liquid is near, the correlation is good about the simulation and experiment, but in the sulfuric acid, it's too high, I think. Maybe this is because of the K value in Maria's experiment is the K value of ionic liquid. And the K value number is 0.003815. Okay, after we have the simulation, we can see there's a big difference between sulfuric acid catalyst. That's why we need to determine the new K value. From the Maria experiment, I have a conversion value, and then after I have a conversion value, I enter the conversion value to this equation, and then I do the MATLAB simulation, and I have a new K value for the ionic liquid is 0.0038, and the sulfuric acid is 0.0065. And this is the new graph of the new K value simulation. we can see from this graph is sulfuric acid produce better reaction rate because they can decrease the concentration of FFA, free fatty acid, to the lower level than compared to the ionic liquid. And if we try to check the correlation from the R-square value, I use the Statistica 8.0 software, and we have the correlation or R-square value of the ionic liquid is 0.99526, and for the sulfuric acid is 0.98753. And also we can conclude that is the ionic liquid has a better correlation or a better R value, because if the R value nearer to 1 is the better correlation value. This is the comparison decreasing concentration rate between first order and second order to the Marias experiment. I believe the Marias experiment used the first order reaction, because the second order reaction is the difference is bigger than the first order reaction. Let's check from the software. From the Statistica software, we also can see the first order has a 0.99526, and the second order is 0.89483. So the Marias experimental suitable for the first order reaction. And this is the graph of decreasing concentration of methanol versus methyl ester. We can see there is the black one is the concentration of methanol. They will decrease by time, and also the green one is the free fatty acid value, and then the pink is the methyl ester. From this graph of simulation, I believe this Marias experiment has an optimum yet. We can do some of various advanced experiment to produce the better metal ester conversion. This is the kinetic parameters of each temperature. I got this K value also from the MATLAB simulation with the conversion from the Marias experiment. I check each time of temperature, and after I compare the K value between experiment and simulation, there's no much different. There's just a little bit different between the experimental and the simulation. And this is the final kinetic model. This A value I got from the MATLAB simulation. The new A value is 1.0384, and the energy activation is minus 89.5, and the new reaction rate equation is mean RA equal to mean dCA per dt equal to 1.0384 exponent minus 89.5 per RT multiplied by Ca, concentration of A. And the conclusion of my research is the best conversion obtained from the MATLAB simulation result was 0.45 4565 or 45% for the amount of 3% liquid ionic liquid catalyst and 63% for the 3% of sulfuric acid catalyst. And then the residual concentration of reactant obtained from the simulation is 0.0996 and 0.1075 for the experimental results, with percent error of 7.37%. And the reaction rate for my area value is 0.0038, and for my thesis or my simulation result is 0.003815. Sorry, my simulation is 0.0038, and then the experimental data is 0.003815. And the validation of the suitability between the simulation experimental obtain a very close correlation with the value of R square is 0.99526 for the ionic liquid catalyst, and then 0.98753 for the sulfuric catalyst. And the energy activation value minus 89.5, and the A value is 1.0384 for the simulation result, and for the experiment 0.437 for the energy activation, and then A value is 0.012 for the experimental. Now, the validation of the suitability of first second order reaction, the R square for the first order is 0.99526, and for the second order is 0.89453. And advice for the advanced experiment or advanced research, we must find the optimum reaction condition so we can have the higher energy conversion, a higher metallizer conversion. And study about catalyst preparation is needed because the sulfuric acid conversion is higher than ionic liquid. Okay, that's all. Thank you. That's all for my presentation. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, right, thank you, Agang.
Ya kan dia mahasiswaku. Dia kan mahasiswaku. Duha kan dia mahasiswaku. Nah, ora PPK.
Yeah, okay. Okay, right. Thank you, Agang, for your presentation. And it's been for the second time. So I think we have listened what he has done so far. And first, we have his presentation during the result presentation, and today we have him again for the second time as the monthly postgraduate presentation as one of the requirement before he goes for the final thesis examination. Right, so any question from the audience in regard to what Agang has presenting this morning?
Any question, guys?
Yeah, I'm glad today we have 22 participants.
For the information, actually, I just continue the Marius experiment, sir. Professor.
It's fine. Yeah, because due to the condition, it is almost impossible for you to do any lab work anymore.
Yeah.
So it should be fine if you do with any modeling or data analyzing in future, more detailed explanation and as well the in-depth understanding on what someone has done before. So it should be fine. So any question from the audience? Ratih, any question from you?
I'm Kian. I have a question.
Okay, again. Yeah, okay.
Usually, in order is the highest order. This in this experiment in one order and second order. Usually, the highest order are must nearest the experiment. Apa?
Yeah.
Usually more
Have
same
better correlation
better
rate, yeah.
relation.
This
Nah, in this experiment, why in the second order is more not apa? Not same gitu.
Yeah.
The best is
Thank you
why
for the
the best is in one order, first order.
Yeah.
Thank you.
Yeah, you're welcome.
Yeah. Why first order reaction is more appropriate for this case?
Okay. Thank you for the question, Gian. There's also the question in my mind because I did the same the same kind of thesis for my bachelor degree. I try to analyze the kinetic study of esterification too, and the result is the second order has a better correlation value. Is it difficult for me to answer this question actually? Because the fact is the first order has better correlation rate. Maybe because of the excess of methanol in this esterification reaction. The methanol is didn't too much has a contribution for the reaction. Yeah, maybe that's all, Kian. It's difficult for me to answer the question. That's good question. That's you are very smart. Thank you.
Okay, thank you.
Maybe
Okay.
you can help me, Professor.
Okay, actually, Bagus, Agang, actually, you have mentioned earlier in your presentation, the reaction should be best for the second order. It should be best in the second order. Unfortunately, Maria, she did the experiment where one of the reactant was in excess. Yeah, so methanol was set in excess. So because actually the reaction should be in the reverse direction, should be reversible reaction. First goes to the right to the product, and then at one time as well, they should go to the left to the reactant. But because Maria did the experiment and methanol should be in excess, so the multiplication, the product between multiplication between the K value and the methanol concentration will be almost constant. So it should be K and then concentration of the fatty acid multiplied by concentration of the methanol. But because the concentration of the methanol was in excess, so the value should be about the same. That's why you finally get only first order reaction. Yeah. So finally, you get the first order reaction. It's okay.
Yeah.
It's this follow what the approach was done by Maria actually. Yeah. So it doesn't matter. It is not compulsory that second order reaction should be better performed in the case, because one of the reactant was set in axis. The second order reaction may be working when the initial concentration of the reactant were not in axis. So each of the reactant will have different concentration. Then it will provide each at the first order, and then the concentration of the methanol also first order, then you will have a second order reaction. Yeah, so in your case, because Maria did the experiment where the methanol was set in axis, so it is good. It is following the approach that you finally get the first order reaction.
Okay.
So the result is correct.
Okay, thank you so much.
So Gian, you got the answer?
Yes, sir.
Yeah, because one of the reactant was set in axis, so there is no effect. Yeah, there is no effect from the second reactant, which was the methanol, because in axis. So the multiplication between the rate constant, the K value, and the concentration of the methanol, their product will be constant. So you got only depending on the fatty acid concentration. So that's why Agang finally get only the first order reaction will be the best approach.
Thank you
Okay,
so
any
much.
other question? Yeah. Okay, any other question? Yeah, we still have Fabio. Any question from you?
Not yet, sir. I
No.
think next presentation.
Okay. Jetro, any question?
Perhaps not right now, sir.
No, at the moment. So, Indra, any question from you?
Yes, bro.
Ahaki, you have question for your beloved friend?
Just say hello, sir.
Hello, Haki.
Hello, boss.
I'm glad that both of you are here this morning. So we have as well. Okay, right. I think I should give some a resume. Rati, any question from you, Rati? Salahuddin, any question?
Not yet, sir.
No, yeah. Teguh, any question from you?
No, Prof. Thanks.
Okay. Laura, any question? Laura is sleeping, yeah?
Not yet, sir.
So, okay. Okay, can you just show me the graph between the concentration of the fatty acid versus time? Maybe the first or second graph. I just want to make it clear. No, the next
K
one.
value or the old K value, sir?
No, the next one, Next. That one. Okay. This result shows us the concentration of the fatty acid versus time, where the dot symbol represent the experiment by Maria, and Agang put two approach from the first order reaction, with the dot with the small dot line, and then the second order is the full line. You can check here that. But Maria did as well using the ionic liquid, right?
Yeah.
Okay. So that's what I have mentioned earlier, that the concentration of methanol, because methanol was set in excess, then it didn't give any effect on the rate of reaction because methanol was set in excess. So the concentration of methanol will be always high. Then what we see in this figure, that the concentration of fatty acid only will change with time. The only problem is when we are using this first order reaction, you can see when the time beyond 150 minutes, we should have a constant value of fatty acid concentration from Maria data. Yeah, the data from Maria, we can see that beyond 150 minutes, there is no more change in the concentration of the fatty acid. But Agang approach using the first order reaction, it should be the concentration of the fatty acid should be remain decreasing. Yeah. Then we can conclude here that actually the reaction after 150 minutes, that will be reversible reaction because the concentration is constant. No further decreasing. If we expect that the reaction will be in one direction only, to the right, then the concentration of the fatty acid should go decrease. But from the data, we can see here that beyond 150, the concentration of the fatty acid remain constant, meaning that the equilibrium has been achieved. So that the equilibrium has been achieved. So we cannot expect a higher conversion after 150 minutes. So that is the highest conversion that we can achieve using this condition. At what temperature, at what ratio between the fatty acid and the methanol, and what the concentration of the ionic liquid. Unless we change the concentration of ionic liquid, then we can expect that the concentration of fatty acid may go further decreasing. But at this condition, then this is the highest conversion that we can achieve. Yeah. So that's why we should consider at this time that the reaction is no longer irreversible. So the reaction is already reversible because it already achieved an equilibrium condition. Yeah, as you can see here, it's very clear. Yeah, you can see very clear after beyond 150 minutes, the equilibrium condition has been achieved. So you cannot increase the conversion, you cannot decrease anymore the concentration of the fatty acid. And as well the concentration of methanol. In regard to the difference between the approach using the first and the second order, I have mentioned this now. The approach, because Maria used excess of methanol, then of course we will go with the first order reaction, which is true. Yeah, which is true. If you got the second order, then there's another wrong.
Yeah, alhamdulillah.
Yeah, if your calculation result shows that you obtain the second order reaction, then you are totally wrong. Yeah. luckily based on Maria results and all the condition that the methanol was in excess, and then the condition is what you have mentioned during the presentation, then the result is good. Yeah. Okay. Make sure you show another result a little bit more. Okay, here we can see the concentration of the methanol. The pink color after 150 already constant. Yeah. Methyl ester, sorry. The methyl ester concentration is already constant beyond 150 below. Yeah, which is in a cross with the green color. The green color also almost constant, the concentration of the fatty acid. And of course, the concentration of the methanol will also constant beyond 150. Yeah, so at that condition, meaning that the reaction already achieved the equilibrium condition. So I hope that you may add this point to your thesis.
Okay.
Yeah, that might be what I read on the result or your journal submission as well. Maybe something maybe you can add that the condition for the equilibrium has been achieved at that time. So maybe you can see, you can show another result further, a little bit more. Okay, the kinetic parameters. Yeah, this is the procedure how to get the correlation between the K and the temperature. Okay, next. This is the simulated value and the experiment. Of course, the result will be the same. Yeah, I don't think that these results should be compared, Agang.
Okay.
Of course, it should be the same. Yeah, of course. It's definitely the same. Okay, next. Okay, one more thing. Back to the picture. Back to the picture. This one. I think it is best for you to show the temperature in Kelvin, not in degrees Celsius.
Yes, sir.
Because when you calculate the K value and the temperature, which is K using the Arrhenius equation, is in Kelvin.
Yeah.
Yeah, so it's best for you to use the Kelvin, not the degrees Celsius. Okay, next. This one is real. Then we can see here. So the value for A and at activation energy, that should be the same. So I don't think that you need to compare these two, because it should be the same. Because your graph just now, they are the same. So the value should be the same, Agang.
So I don't need to.
You don't need to show this.
Okay.
Just put the value. That's okay. Because pay back to the picture, the picture before. Yeah, this one. So you can see that the result from the experiment and the simulation, they are the same. So the A and the frequency, the collision frequency should be the same, and then the activation energy should also be the same. So when you show table, the last table, they are different. It's weird.
But the value is different, sir. 1.0384, and this one is only 0.0.
Yeah, that shouldn't be happen. Because the K value is the same, then the result, the value should be the same. Because just when you show the graph, the rate, they are the same. This one, they are the same. Why the value becomes different? So it's
Let me check the MATLAB program, sir.
Then you don't need to show this. But what you have to do is only you show how the value of course you cannot get the value from the experiment. The value of A, the value of the energy activation always from the simulation, not from the experiment. The experiment only show you the change in concentration of the fatty acid versus time. That's all. So what you have to show here is only the frequency collision number and as well the activation energy. That's all. So the right side just delete.
Yeah. Okay.
Okay, then you just make it proper on your conclusion, then should be okay. Yeah, just put on the conclusion. You do need to show the frequency of collision number as well and the activation energy from the experiment, and should be fine. Yeah.
Yeah.
This is enough for you to show the activation energy and the collision number from your simulation.
Okay, sir. Okay, Professor.
Yeah, that's enough. Okay, so before I close this session, any questions from the audience? I think everyone is now clear that when you are working with reaction and one of the reactant was set in exist from the stoichiometric requirement, then it may change the order from the